Hey there, this is my CS312 final project video. My name is Christopher Bahr. Here's a picture of me, if you remember me. Okay, so my project was to be able to use computer vision to identify whales by their unique flukes. There's four sub-goals were detecting a whale tail in an image, analyze the whale tail by color and shape, um, match two separate images of the same whale tail to be able to say if they're the same whale, different images, and be able to do this with a reasonable level of accuracy. Um, Okay, so the first thing, detecting the whale tail, I figured really the only way that I found online that makes sense to do that is by using deep learning. There were a couple other things that I did as just part of my research that I looked at, like convexity defects, just basic shape detection, but the problem is this is just too simple. These are not the kind of, these shapes are really easy to tell, but they're just basic polygons. And so I figured deep learning is really the only way to go. And so I used this tutorial to basically get me there. It's all about using this thing called YOLO v3 in conjunction with darknet, which is this thing called, it's this idea that you use a pre-trained model inside your larger detector that you're training yourself. It's called transfer learning. But essentially, I know I was using this tutorial with OpenCV. All of this is working with OpenCV. It's not like it's a standalone thing. To be able to detect whales in an image. And I was able to do this because, well, at least I was able to get all of the online training data and photos, like this, for example, just photos of whales, as well as the label files that tell you where in each photo the whale is, etc. From Google. Open Images is a free-to-use open source database of just images and labels so that you can do your own deep learning at home. So I was using that for this. Thankfully, gratefully, they have a whale class that they actually study. Of the like 300 or so classes that they study, one of them is whales, and I've been using that. The first issue I ran into was that all of these things, all of the tutorials I could find are using things like wget and sudo you don't necessarily need to use, but they're using mainly Linux based commands. And so I figure, hey, I have the Windows subsystem for Linux on my computer, so I'd use that. What I didn't realize before I was done with the 9 or so hours of configuration, installing, dependencies, getting, OpenCV, cut-in, all of these random crazy things installed on my Ubuntu distro, was that Windows Subsystem for Linux actually can't access your computer's GPU, which is totally important when you're doing deep learning, because that's your workhorse. The GPU is actually able to do a lot of the computation. So I actually got it done. I got it to actually work. So this is it running right now. Well, now it is. And we can even check that if we look in our task manager here. Darknet's using 10% of the CPU, about 3 gigs of memory, and this actually keeps going up. I at first, when I didn't realize what the issue was, I left this on for about 2 hours, and it didn't do even a single iteration. It did essentially nothing. So I've read online that there's really no other way around it. You need to use your GPU, and so I figured, hey, I may have wasted 9 or so hours on this, but I might as well just jump into doing it on my computer. So on Windows, yeah. All of that's obviously on my computer. So I installed. I had to install OpenCV again on my computer, which then created issues with OpenCV that I was using in Visual Studio Code versus Visual Studio. I had to download CMake and do this totally insane sort of like I use this image online to be able to like match up the kind of build that I'm doing and make sure that all the things are the same. Maybe it's not so insane, very new to me. And it still didn't end up working in time. So I mean, I'm not admitting defeat, but I will say that given the amount of time that I had to do this, I was not successful in being able to actually prove that I could build a deep learning machine and get it to actually detect whales. So that's, I mean, there's not much more I can say about it. That is the first goal I did not succeed in. But I didn't, place all of my weight on only that goal. I figured, hey, if I'm having issues here, and it's funny, I didn't actually start there. I started with like analyzing the tail and figured that this would be something I could do towards the end. So that second one, just here is my project, and I can kind of explain everything that I'm doing and the reasoning behind it piece by piece. So this is, again, just analyzing the actual whale tails. We'll assume we already have them. I already have thousands of pictures of whale tails and some that are labeled as known matches. So we'll start with just these two that I know are a match. And we just go, I'll show them step by step what I'm doing to each picture one at a time. So start with the first one. This is the image that we are analyzing. None of the images are very high resolution, but these are the images that whale researchers are actually using, so it's not so unreasonable. And so some of the things we're going to look at here is we want to analyze the shape of the whale, it's the whale tail itself, because this is like a fingerprint. This is a very unique growth. This isn't necessarily damage on the tail. These are just the way that they grow. And one of the things that we're looking at that we're lucky is that all of these images will take place on water. So that means that in the background you have a generally a well, there are a couple things that you can look at. What we can't assume is that there will always be sky in the background, because sometimes some of these pictures are taken from a higher elevation and there's only water. We'll always know that there's water, but we won't necessarily know if there's sky. So we can't just assume there will be sky and assume there won't, that there will always be water. We do know there always will be water. But another thing that we look at is that it's kind of interesting. Almost all of them follow this pattern. You have black on the outside, and then the white will be on the inside. Sometimes there's less white, sometimes it's more black, but essentially we have this sort of outline on the outside of it in a dark color, which will be important for later. Kind of gave me some initial hope that I might be able to isolate the shape of the tail. So one of the things I noticed, though, we'll just go forward by one, what I've done here is just increase the contrast of the image. And I did this because if you look at some of the dark like lines here, you'll actually see that they're kind of brought out a little bit more. You're actually better able to see some of those dark shapes, which are so important. Those are the ones that we're actually going to be testing for. Something to worry about was, just getting the contrast just right, because I didn't want the shade to be so dark that I started to pick that up as well. But it was important to me that and there could be some more tweaking I could do on this, maybe adjust the saturation or something like that. But I was working on it for a while. Anyway, increase the contrast so that we get some of these shapes brought out a little bit more. Unfortunately, that also does bring out the color and the shapes in the water, but not much we can do about that. Now, the next step is that I invert the colors of the image, and that is actually this sort of a transitory step. I invert the colors because we're going to be using something here called the watershed algorithm. I'm not super great at explaining it in layman's terms, but essentially, if you think of an image as a topographical map, and then think of all of the dark areas as valleys and all of the white areas as hills, then that's kind of basically the idea. Now imagine you fill that topographical map with water, and the places, the different pools that are formed are the segments that are being generated by the watershed algorithm. That is why I flip the color of the image, because I want to take advantage of this white outline that we are so lucky to have here, just because of the natural way that whales are colored. They have white and black on them. I mean, that's pretty lucky. So this is just a middle step. Unfortunately, I won't be able to show you the next two steps, which, if we're looking over here at the code, this is the flipping, and then we're about to do something that is it's called the foreground-background extraction, and that's the actual thing that uses the watershed algorithm. It's just up here, and so yeah, you can see we do a couple things in here, but I will just continue. So these are the two things that we did. We don't actually show the foreground background extraction before we do the canny edge detection. That's because once we do the foreground background extraction, it's a I think I've had an issue kind of trying to figure it out, but essentially it's the image at that point is in a state that you can't really show it. Um, it doesn't have 3 channels, which I figured, hey, maybe it's just a gray, but it's not quite. I mean, it doesn't matter. This is our, we're using the canny edge detection, so this is the binary image that we're wanting to get, which will accentuate the shape that we're looking for. I really want to focus what I realized was that we don't actually really need to look at the color as much as the colors are so different that they'll create different shapes. We're just looking at the shapes. And one of the issues that you'll see here that I didn't have in other iterations just because it's a trade-off is that we get this beautiful, perfect outline of the outside of the whale's tail, but we lose a lot of the inner, the lines that we were like preserving by increasing the contrast. And it's only this way because of the settings that I have on. If I tweak it a little bit, I can have it so that the lines are much more pronounced, but then we also get a lot more of the water and background as well. So it's a trade-off. It's not ideal still. If you just look at the image, you can already tell there's a huge issue. We're catching so much of this water still, and we don't want to be analyzing any of that. And you'll see that's an issue going forward. So this is the actual contours. This is just an image, but these are the actual contours that are being cut out and analyzed that we could actually use to match later on. And what I've done here is I'm just drawing the largest. I've sorted all the contours by their area, and I'm just showing the largest one just to illustrate a kind of point here, which is that this looks like it's one contour. All of these look like one piece, but they're not. I mean, it's hard to even see where the tiny like little pixels are missing, but this is one contour and they're being separated. Not honestly entirely sure what I could do to fix that, but I'm certain there is a some sort of workaround or solution that I could come up with. But this is just to show as far as I've gotten, where I'm trying to isolate as much as I can the shape of this whale tail and set it out from its background. I've been partially successful in that, as far as its background and a lot of the water here, but we're having issues here in the foreground. Now, on to the next image. So here, it always shows in the back. Okay. So here is the second image. If you look, it is the same whale. You can kind of tell looking at the things. Already a little bit along here, but already you can tell. So this is one of the issues that I was having is I was making this assumption, you want to be able to make assumptions about the data. The problem is, I assumed the whale's tail is white and black. I mean, it's both the extremes, and so blue is in general not going to be nearly as bright as the whale's tail. But that is not true. I mean, look at this image. You can tell that the sun, the front of the tail is between the back of the tail and the sun, and that the center regions, the white regions of this tail, are not even as light as the white regions of the water, because it's getting direct sunlight, and it's definitely not nearly as white as the actual splash here. So this is a huge issue where we would be served so much and by being able to detect the actual whale tail and not just take the entire image as it is, because as you'll see going forward, our edge detection basically negates the whole shape of the tail. I mean, we've got only the water here, which is about as far from. This is the exact opposite of what we want to happen. And finding a solution that is applicable for both, this image and the previous one is difficult. It's a lot more serious of a process than I thought it was going to be. And I've done some research on things that I could do to improve it. There's this thing called marker-based watershed. It's an adjustment on the watershed algorithm where you can put down a marker. You can manually go in and add a kind of coloring around the areas that you don't want to have be affected. And that, I think, could give some better results. Again, this is just showing off how many of these lines are totally separated. This is the largest single segment contour in this entire image, which is just, it's pitiful, it's tiny. This is horrible. This is nothing that we want. This is not, I did so. I was really thinking about it, and I was really trying, but didn't get quite nearly as far as I wanted to. This is just going to show you how poorly this this is going. I pretty much added this step just to kind of show you where I was trying to go with this. I knew that this wasn't going to work, and it was going to look bad, and it does. So there you go. Um, okay, yeah. So I would say, based on if I have to grade myself, and I know I'm grading myself, I would kind of look at it in three different ways. If I'm grading myself based on effort here, with the amount of work that I put into this and the amount of thought and everything that I did, I would give myself probably a B minus. The whole coronavirus thing definitely didn't help anything. I got sick for about a week and a half around week 8, and that threw me off. And again, I get that it's my fault that I didn't get enough work done, but it took me time to get back into things. But I would give myself a B minus. I worked pretty hard. Um, as far as what I learned in this project, I'd give myself an A. I've learned a lot, and it's been honestly really exciting working through this problem, especially because I want to solve it. And I'm not done. The class may be over, but I'm going to keep working on this. If I was grading myself based on what I actually got done, if I'm talking about basically these things here, there's really no other answer but F. I didn't get any of them done. Not a single one of these things was meaningfully achieved. But I do think I proved that I have at least some idea of how to move in that direction. Um, so yeah, I learned a lot. I do have some things to point out. I wish I had done maybe better research before I really started digging into this project, or honestly before I even made the proposal, because I saw some stuff. I realized when I was looking at the open images stuff is that they have segmentation now with deep learning, which is just incredible. You would not believe the feeling I got when I opened up their open images website and saw this image. I mean, oh man, it's insane to me. And again, this is kind of why I'm excited to keep working on the project. But this is like most of it's already solved at this point. It seems it's not. I'm sure it's not trivial, but um, using this is going to make it a lot easier on me if I can get it working. Granted, it takes me 10 hours each time I try to install this stuff. Um, I think that this is a great way forward, and I'm excited to start using this a lot more. I've been doing research on how I could have better done this, and it's a little frustrating, but oh well. I don't want to waste your time. That was my project. Thank you so much for your time. Thank you so much for the semester. It was awesome. If I want to say something personal here for a second, I am super grateful. I'm super, yes, grateful to you that you made a lot of your assignments due on Mondays, because it gave me the ability to not work on Sunday, and that's something I'm really grateful for. Just because it's something I struggle with, and it's something that's very important to me. So, thank you so much for that, for incentivizing that. You're a great teacher. It was a great class. I've had your classes 2 times now, and I'm going to look for them in the future. Thank you so much.